In this problem, we're going to look at how the change in temperature affects volume, and the equation that we can use is that the change in volume is the bulk, or the coefficient of volume expansion, times the original volume times the change in temperature. Notice that this is similar to the one we used for example 2 on the length, except now it deals with volumes. And we have the tank, which we'll say has a change in volume because it's made of steel, given by the bulk for the tank, the original volume of the tank, times the change in temperature in the tank. And then we have the gas, which has a change in volume, delta Vg, given by V sub G times delta T. And the spill then is going to be the difference between these two. So it's going to be the delta V gas minus delta V S. Plugging in the equations, we get V sub G delta T minus V sub S delta T. And we have a delta T that is common, so we can factor that out, and we get V sub G minus V sub S. And then we note, if the tank is full, then V sub G is equal to V sub S. So that means that the spill then is going to equal delta T. I can now factor that V sub G, V sub S. If I call it V, then I'll have a V out here, and then I'll have V sub G minus V sub S. The volume expansion coefficients we can look up in a table. The change in temperature, we're told, is from a 15 degrees Celsius to a 35 degrees Celsius, so that's a 35 minus 15 in degrees Celsius. The volume is 60 liters. We're told that's how the capacity of the tank is. And then if we look up these in the table, the coefficient of volume expansion for the gas is 950 times 10 to the minus 6 per degree Celsius. And for the steel, it's 35 times 10 to the minus 6 per degree Celsius. Computing this, and we get a 1.1 liter. One of the reasons why you are asked not to overfill your tank is because of this spill factor. If your car is pressurized and you have a lot of this spillage, then it could lead to not so good things. This will end example 3, and we will move on to example 4.